What is up, most distinguished patrons of this channel? Today is a viewer special. I have Brad in the shop here.
I'm back.
And we're going to be doing something probably pretty stupid, but maybe necessary, and that is stick welding with car batteries. So that's what we're covering. Let's get into it. All right, well, a viewer requested this, and I'd been planning on doing a video on this, and at no better time than the fact I'm going wheeling this upcoming weekend. But anyways, we have 2 car batteries, jumper cables, some wire with a stinger, which you probably wouldn't have if you're doing trail repairs or welds out in the middle of nowhere. But what our plan is to look at the feasibility of stick welding off of car batteries. Now, keep in mind you need 2 batteries to do this, and I'll explain why in the book learning session that we're going to have that's real short. But we got, like I said, the jumper cables. We're going to look at 1/4 inch steel, 3/16, and 1/8 inch as well. And we're going to be welding with 6011, 7018, 7014, 6013 of assorted sizes, and we're going to see what happens and what is the best combo. Now, I have no idea how long that this type of a setup will last. Probably 10 to 20 rods, not much, but probably enough to get you out of the woods. So with that said, let's talk a little bit about book learning on this, and then we'll come back. A conventional stick welder like this, which is a representative of my Dial Arc 250, has regulated amperage, or in the welding world, it's called constant current. CC is what the welder would be labeled as. And you adjust the amperage via a dial, or however your welder adjusts with the stick welders, and that controls the maximum amperage the machine will allow through. That works great because you can regulate your heat input more or less. Well, when you use batteries, such as depicted here, you don't have any means of regulating current. So you create a electric arc, which is sort of a form of a short. However, you have no regulation of amperage, which in practice, I believe, is going to function where if you cram the rod in, the more you cram it in, the higher the amperage will go. On a conventional welder, you typically will stick the electrode if you push it in. Well, with batteries, it's just going to keep upping and upping the amperage until, well, something gives, aka your rod completely melts, your wires hooked to the rod melt, or the batteries themselves fail, which the batteries will handle a pretty high discharge, so I doubt that's going to be an issue here. But it should, and I know it's going to weld completely different than what you would expect a normal conventional stick welder to weld like. So your arc gap, you're going to have to maintain one, and it's probably not in your best interest to try and shove the rod in and hold a tight arc, because you're just going to have excessive amperage. And that is why I think we're going to get fairly poor results. Yes, things will be glued together. Yes, it'll get you off the trail or out of the mountains of Afghanistan, but the quality of what we can expect today is going to be minimal at best. The cool thing is, because I'm at a little bit higher skill level than Brad is, we'll be able to see if this is even an approachable option for someone who has a little bit of skill, who can run a couple beads, versus someone who's higher skilled. If neither one of us can get decent results, well, then you know that you probably won't either. But like I said, we're going to get some kind of results with this. It's just going to be tough, I think, to get decent results, and our results are going to be better, I have a feeling, with particular rods and diameters than others. And I also think that the thickness of what you're welding is going to matter hugely. I think anything thinner than an 1/8, that you're simply going to have too much amperage and you're going to melt. And it kind of goes without saying that, like, say 1/4 inch or 4 to 6 mil steel, like this stuff right here, you can almost put unlimited amperage to that and not melt through it. So 1/4 inch, I think this is far more feasible than probably 1/8, and especially under 1/8. Now, the last thing I'm going to mention is, depicted here with the batteries, you must run 2 batteries to do this if we're talking 12 volts. And the reason is simple. A normal stick electrode, and this is a 7018, operates at about 24 to 25 volts. And if you have 2 batteries run in series, you can get about 24, 25 volts. If you have one battery or two batteries run in parallel, you're only going to have 12 to 13 volts, whatever your battery is, and that is simply not enough to weld with. You may actually be able to TIG weld with that, but you will not be able to stick weld. And therein lies the problem with this whole thing. You're definitely going to need two batteries to do this to get high enough voltage. Now, three batteries where you'd have 30 some volts, 36 volts to 38, I think that that's going to be simply too much voltage, and I don't anticipate that this would work very well. You might be able to run 6010 with that high of voltage and make a weld, but conventional rods, your 6013, your 7018s, all of those, they're not going to function properly with that kind of voltage present. If you had to do a lot of welding with a battery setup, it would be in your best interest to have four batteries where you basically put two sets in series and then you parallel the both sets to give you more amperage capacity, aka you have more runtime. As far as how many rods you'll be able to run on batteries, I'm not really sure, to be honest. I bet a set of series batteries, you'd probably get at least 12 or 13 rods, I would hope, but that's not really that much. And the last thing you want to do is drain your battery to where now you can't start your vehicle to escape the alligators and stuff out in the jungle. So anyways, with that said, let's get back to actually testing this crap out and see if it works. So here is our setup. We're running them in series, so we have the jumper cable linking the positive to the negative. We have the output clamped to this stinger wire, and the negative here is back to the ground clamp on the table. Now obviously in the field you would probably not have DINS connectors to hook this crap up, so you could actually use the jumper cable as your stinger and as your ground. I'm just taking the easy approach, give this any kind of feasibility of working. So what are your thoughts on this setup, Brad?
I don't know. I hope they don't explode. That's all I can.
Okay, great point. Brad brought up the fact that there is actual legitimate danger in doing this, and that is, well, for one, we have two different batteries with different amp capacities, different resting voltages, different ages, and you want to be smart about this. Like I always say, if you're going to be dumb, be smart about it. So we have these off of the welding table, and we'll probably push them a little bit further away so sparks don't start flying on top of this. That would also be bad. But it goes without saying, you probably shouldn't do this with the batteries in the vehicle because of the possibility of a fire or an explosion. Now, will we see an explosion today? Highly unlikely, but be smart about it. All right, let's go back up to the welding table. All right, I got a 6013 1/8-inch rod chucked up in the stinger. First attempt at this, and obviously we have unregulated amperage, so it's going to be whatever it is, and the tighter the arc you hold, the more amperage you're going to output. And I'm going to do an attempt, run a bead, and then I'll let Brad run a bead on it. Smells weird too. Smells like barbecue sauce from McDonald's. That's pretty weird.
That's weird, yes.
Doesn't it smell like?
Yeah, sitting in the car for a couple days, yeah.
Yeah, so I had to cram that rod in there and just keep pushing on it, and it barely kept the arc lit. So I'm going to take a guess right now and say the 1/8-inch rod is probably not going to work that well. I bet the 3/32 will probably work better. All right, Brad, let's switch and you can give this a shot. Yeah, you gotta knock that off. It actually doesn't want to start at all. All right, break off the tip with your fingers. Just squeeze it. There you go. Now it'll start. I forgot, because the voltage is so low, it doesn't want to start. Yeah, hit it harder. There you go. You're doing better than I was. Wow.
It's like I was destined for it.
Yeah, you did better than I did. So here is my weld right here, and here is Brad's. And the slag peel looked terrible. Like I would not have thought this decent of a weld would have been underneath it, but it worked in the sense that 60-13 1/8-inch rods, so 3.2 mil rods, you can make a weld on 1/4 inch, and it does glue stuff together probably, so that's more than I would have thought. So feasibility of it, I'd give it a thumbs up with 1/8 inch 60-13. Now let's try 60-11. All right, so we got 3/32 60-11. Let's see if this will run. This takes more voltage than the 60-13, but it'll be easier to keep the arc gap tight because of the lack of flux. Yeah, that isn't going to work too well. I mean, I'm cramming the rod in, it's digging the plate out, barely producing an arc, and I'm going to say that that's a no-go on that one. But let's give Brad a shot at that. Maybe he can perform his magic. Wow.
There it goes. Campfire Central.
Wow. That took about 1 millisecond for that to burn the flux clean off of it. Look at that, it's just falling off. All right, 60-11, that's a no-go. Now we have 1/8 inch 60-11. Let's see if we have a little bit better result with that. Man, you really have to run a steep rod angle and just shove it in, and more or less how much pressure you put on the rod controls your amperage. I don't know that that's going to look any decent when we clean the slag off, but at least that ran. I think the 1/8 inch rod is feasible. So we have a blue rod here, which is a knockoff 60-11 by US Forge. It's just called Steel Guaranteed, guaranteed to work. Well, we'll see if it works with car batteries. That's pretty weird. That ran better, and this is what, 3/32. That actually ran better than the 3/32 60-11, but it doesn't look good. Huh, weird. All right, give it a shot, Brad. So that particular rod actually ran better than the 60-11, and Brad, he switched to like a weird push angle, and it actually worked pretty good and stayed lit doing that. So that's something we learned that might actually work. We'll have to try that some more, but that particular rod, I would say, is doable on car batteries, shockingly. Pretty easy to run, a lot better than 60-11. So we're going to try 70-14 1/8 inch rods and see how those run. Pretty terrible, but it stayed lit. It's about what 60-13 is, probably a little bit worse. Well, that ran I guess a little bit worse than that blue rod in 6013. It made welds are not really great looking, but as that rod heated up, it seemed to weld a lot better. So that's quite interesting. Well, let's test 7018 now. Yeah, the flux, once it burns off, you're in trouble. It won't restart easy.
It really.
Yeah. Let me give that a shot. What's going on is it's burning up just like a normal 7018 does, but the second the arc goes out, you can't restart easily. So I don't think this is even going to work at all, but I'll give it a shot. Yep, that's going to be a no-go. It just burns up too high. It self-extinguish, and you're not going to get a weld out of that. So that's definitely a no-go. All right, well, let's try and do some welding on plates. So Brad and I determined that 6013 is probably our best shot. I'm going to take an 1/8 inch rod and try and weld 3/16 thick steel with this and see how it goes. Looks like dog turds, but I bet it'll hold.
Beautiful. What the?
So here's the results of that. This is 3/16 to quarter. It fuses stuff together, but man, with that 6013, slag entrapment and stuff is going to be an issue. I think this was Brad's. I don't remember, but it's doable, not the best. I have a feeling those Blue Rod 6011 knockoffs would actually probably do a little bit better. But I think what we're going to do now, we're just going to weld 1/8 inch material. So I got 6013 here, same rod, 1/8 inch rod. We got 1/8 inch material. Let's see if I can do this. So this actually, I would say, pretty successfully welded with 6013 on 1/8 inch material. That doesn't look that bad. This side's a little bit rough. I don't know who welded what, but it's still, most of it's actually pretty decent. And this on a trail repair would more than likely get you out of a bad situation. So 100% on thinner material, it's doable. Well, let's go to conclusion. In conclusion, what did we learn today? Well, we learned that it's feasible to stick weld with car batteries, but man, the results are going to be pretty hit or miss. What do you think about it, Brad?
So glad it didn't blow up.
Yes.
I'd be interested to see what the voltage on the battery is at this time.
Yeah, it's probably pretty far discharged,
yeah.
I would guess.
Yeah. Yeah, surprisingly, I mean, what's the blue rod, the 60
11 knockoff.
knockoff.
That ran, I think that's
yeah.
feasible.
Yeah.
The 6013, feasible.
Yeah.
7018, that's not going to work. It wouldn't even stay lit. Normal 6011 didn't run very well either, and you, as a matter of fact, lit a rod on fire. This guy right here.
Yeah, fun
That's
times.
about the most cooked rod I've seen in a split second.
First time for everything.
Yeah, right. But yeah, so if you're on a trail or somewhere stuck and you have access to 2 car batteries and a jumper cable, this on 1/8" material, it's doable. It'll get you out of a bad spot, but in comparison to like a welder generator or that Fronius battery powered welder I got, this sucks. Like, I don't want to be doing this all day.
No, too inconsistent.
Yeah. I rather use, like they do over in Pakistan, one of them transformers that they wire up direct voltage and you weld something with flip-flops. That works far better than this does. So yeah, so there you have it. I guess it's doable. You don't want to make a habit out of it.
Absolutely.
Until next time.
No tank tops when welding.